Hello everybody, welcome back to Tu Akedemy. Today we're gonna learn about ACs and DC generators. First, we're gonna learn about AC generator. What is an AC generator, you might ask? AC generator, also called an alternating current generator if you're a scientist who likes long stuff, is a kind of generators that converts mechanical energy into electrical energy. How? By mechanical energy through the spinning in the picture. The spinning is what I'm going to explain later. But right now, let's go through the bullets. First, converts mechanical energy into electrical energy. Then, uses magnetic fields to induce a voltage, which generates power. This type of generator is used to power many electrical devices that we use in home, businesses, and many more, due to the fact that this is the only generator that every country uses to power up their homes. DC generator is something else, and we're going to talk about that later. An AC generator works on the principle of Faraday's law of electromagnetic induction. When the armature rotates between the magnet's pole upon an axis perpendicular to the magnetic field, the flux linkage of an armature changes continuously. Due to this, an EMF is induced in the armature. You might wonder what an armature is. It's the spinning thing I was talking about a while ago. The armature spins and electricity comes out. Here is a part of a generator, or maybe it's illustration of the part of an AC generator. Rotation, magnetic fields, north and south. You can see north, south, and between the north and south, it's the spinning thing. That's the armature. Connected to the armature, rings. Connected to the pair of rings, you got your wires. This is a short video of how an AC generator works. As you can see, the armature is spinning between the north and south. Spinning it generates electricity. As you can see, different rings, two rings connected to two different wires. Using your right hand rule, you will know that the current is going in and out. One wire goes in current, one wire goes out current, like a normal circuit. But due to the fact that the armature is spinning, if you spin your right hand rule with it, you would see that the circuit that's currently carrying the out will suddenly carry it in, and the other side does the same thing. If it's out, it's in. So it's in, out, in, out, in. Due to that, this is the reason why it's called an AC generator, alternating current. The current alternates. Sometimes it's in, sometimes it's out, depends on where the armature is between the magnets. How the electricity is distributed to your homes is very simple. As you can see, AC generators are wind turbines, hydropower, anything powered. Coal, nuclear powered, probably all AC generator. Not so sure about the nuclear one, but the others, they're all AC generator. You got your wind turbine, you got your ocean turbine, you got your waterfalls, your volcanoes, your coal. They're all AC generators. They spin, makes electricity, and goes to the first box. You see that first box? That's a step up transformer, because one generator and other generators is going to power an entire country. And you know there are resistors in a wire. You can't expect to transfer 1000 from one place to the other place and it maintains 1000 voltage. It'll go down. It's physics. And it's due to the materials we use. Copper, it's a conductor, but then there's still a little bit of resistance. So it has to step up, makes the voltage high enough to kill you almost instantly. Even though it's a 90% mortality rate, I'm sure you don't want to try it. It goes up to transmission lines. Look outside your window, especially if you're in the Philippines. Our third world country, the transmission lines are messy. Look outside, you see those black lines everywhere. Those are transmission lines. Try not to touch them. It's currently still safe to touch them because they have a rubber exterior to not zap people. But then, why would you try it? After it's transmitted around the country, it goes into another box. If you look outside right now and you look for a pole with electricity on it, there's some weird boxes around it that's connected. This is for the very high powered voltage. In your home, you know that the circuits around your house, the sockets, they are 220V or 220 volts. In some other country, it's 110. It varies in different countries, but most of the time, especially in the Philippines, it's 220. You go to China, it's 220. Taiwan, 110. Japan, 110. Other countries, I'm not that sure, but you get the gist of it. It varies, mostly 220, sometimes 110. But how did it go so low? This is because the poles outside have another transformer. This time, instead of stepping it up, it steps down. It takes your super high voltage into the voltage that you can use to power your LEDs, your water heater, your electric fan, your lights, your laptop, your iPad, your mouse, whatever you use, it powers it. So now we're gonna talk about the DC generator after we learn about the AC. A DC generator is also called a direct current generator. Listen, it's not alternating anymore, it's direct. It is a device that converts mechanical energy into direct current energy. It operates based on the principle of electromagnetic induction, where a conductor moving through a magnetic field induces electromagnetic force or voltage. Sounds familiar? Because it's the exact same thing as an alternating current generator or an AC generator. Let's continue reading this. A DC generator were widely used in the past for various applications, including early electric power generating systems. However, they have been largely replaced by more efficient and versatile devices such as AC generator. This is why countries around the world uses AC generators instead of DC generators. How is the electricity distributed out to your home? It's simple. If you look at this illustration, it's the same thing as an AC generator, only one difference. Instead of two rings, it now has one ring that's two different colors. We know that for AC generators, when it spins, the current goes in, out, out, in. It changes. But for DC generators, the wires are not connected to different separated rings. It's connected to one ring. Therefore, when it spins, the wire is always connected to different rings. It connects to two rings, one left, one right. It depends where the armature is. But no matter where it is, the wire's current is always the one way. If this wire goes out, it's always out. There's no going in. It doesn't alternate. That's why it's called direct current. Here is a GIF of how it generates electricity. You see, it looks exactly the same as an AC generator. Spins between magnetic poles, but look, one ring only. One ring connected to two wires. This makes the current not alternate. So why do people use AC more than DC? Many in the countries, including the Philippines, where I live in, our third world country, the most beautiful country, uses AC generators instead of DC generators. That is because the advantage of AC has always been that it's easy to change the voltage up and down. Like I said, transformers. Oh no, I have to transport it 1,000 kilometers away. Let me step it up. Oh, it's now near my house. Step down. It's super easy to do that if you're using AC generators. But DC, it's not that easy. AC has always been easy to change and down with a transformer. DC requires more equipment and some losses to convert. DC generators, you want to convert it, it's very hard. You need equipment, manpower, and you lose a lot of electricity doing it. That's why no countries use it. But that being said, transferring AC power between separate grids require making sure the phase of the power transmitted matches from the two grids. What does it mean? It means two power grids, it has to be the same. You can't send one that's 1,000 voltage to another one that's 500. It's not gonna mix. You're gonna break something. Doing this is very expensive and difficult. But that's not a problem for DC since it's direct. So DC lines are used in cases such as where power is transferred from another grid to increase capacity of an existing grid. So you don't have to rechange the grid. Or between countries that uses different frequency power. You know, countries, they don't just export and import. Sometimes they sell water and electricity. DC generators is what they use to sell electricity to another country. Because you don't have to worry about the grids, you can send your power directly through it. So they use DC generators to send power from, let's say, Yugoslavia to Albania. That might not be true, but those two countries connected together might be true. And the capacitance between the AC phases, usually three phases are transmitted at once over a line or between the line and the surrounding soil or water, causes losses that are not a problem with DC. Therefore, underground high voltage line tend to be DC too. You want electricity from China, you want China-made electricity, no problem. DC it through the seafloor. AC, nah, it's gonna lose. Overall, line loss is also lower per 1,000 kilometers. It means per 1,000 kilometers, the electricity you lose through the resistance is low if you use DC. That's why long distance transmission lines use DC, but in Philippines, everything is AC. These are the reference we used to research about our video. Thank you for watching, and I'll see you in the next video. Bye-bye.